Now, on to our protons, neutrons, and electrons. So you need to go ahead, and if you don't have it out already, go ahead and get out your periodic table. You will need that for the rest of this lesson. You can pause if you'd like. Now, the number of protons, to find that, very easy. It's the same as the atomic number. So if you look on your periodic table, you'll see there's an atomic number that's there, starting with hydrogen 1, helium 2, going all the way up to element 118, which has, guess what, 118. So if you want to simply find the number of protons, all you do is you look up the atomic number. So if we look at how many protons are in the following. Iron, we look up iron, its symbol is Fe, and so we see that iron has 26 is the atomic number. So how many protons does it have? 26. Beryllium, Be, that has 4 is the atomic number, so it has 4 protons. Lithium, it says lithium -4. Now we'll talk about what that -4 up there means in just a second, but for right now we say, does that affect what the atomic number is? Lithium is an atomic number of 3. The -4 doesn't affect it, so it's just 3. So protons is always the easy one to get. You just look at the atomic number and that's the number of protons, period. There's nothing that can change that, because what defines an element as an element is the number of protons. If you had iron that had 25 protons, it wouldn't be iron. It would be manganese instead. You can't have iron that has any more or less than 26 protons, because that's just the definition of what iron is. So protons is easy. Neutrons is a little more difficult. It's simply the atomic mass, whatever that is, minus the atomic number. The only thing you have to be a little bit careful with this is if you look at your periodic table, let's take a look at, say, iron again. The atomic mass of iron is 55.845. Well, if you just did this straight, the way that this one right here says, then what you'd find is you had 0.845, you'd have some fractional number of neutrons, and it's not possible to have a fractional number of neutrons. So in order to find the number of neutrons, you need to know the exact isotope number. And so that's going to be something like, say, on A right here, is he has the 56 out there. That is the isotope number. That's the atomic mass for that particular isotope. You have to know that to find the number of neutrons. Sometimes you'll have people that'll go ahead and just sort of round the atomic masses up, but that's really sort of iffy, because that would give you something that might work sometimes but isn't guaranteed. So you want to make sure that you have some indication that tells you what the isotope number is to figure out what the mass is to find the number of neutrons. So looking at our first one, iron 56, that we said that iron has a total, well, this iron 56, first thing is the atomic mass. It has an atomic mass of 56. And then we're going to subtract from that the atomic number, which you look up there was 26. So 56 minus 26. And so doing that, that tells us that the number of neutrons in iron 56 is simply 30. And so we have 30 neutrons right there. Our next one, you see we have C12 or 12C. This would normally be pronounced carbon 12. This is another way of showing what the isotope number is. The isotope number in this case is the one that is up right here. So this is carbon 12. That means it has a mass of an atomic mass of 12. And so to figure this out, we'd say the atomic mass, which is 12 here, minus the atomic number for carbon. The atomic number for carbon, if you look it up, is 6. So 12 minus 6 gives us quite simply 6, so we know we have 6 neutrons that are in this guy right here. Our next one is our lithium -4. We saw that a little bit before. In this case, the -4 that's up on the right-hand side, compare that with B, where you had carbon 12. The 12 is on the left-hand side. That left-hand superscript tells you the atomic mass. The right-hand superscript, though, is actually the atomic charge. And so this lithium -4 doesn't tell us anything about what the atomic mass is. So we really can't answer this question. We don't know exactly how many neutrons are in this one, because we don't know what the atomic mass is. And so this would be an unsolvable problem right here because of the fact that we don't have that information. And so you just need to make sure that you remember to look for the atomic mass, not on the periodic table to find neutrons, but it'll be somewhere in the one that's given to you or in something else you can figure out. So that's just something to keep in mind. So onward we move to electrons. In a neutral atom, an atom that doesn't have a charge, the number of electrons is the same as the number of protons. Now this makes sense because if I had an atom that has 10 protons in it and I know it's neutral, that means I have to have the same number of negatives as I do positives. And so if I have 10 protons which are positive, I have to have 10 electrons which are negative. And so in a neutral atom, very simple. It's just the same as the number of protons, which is the same as the atomic number. We can, however, change the number of electrons that we have in an atom. We said before if we change the number of protons, it changes to a completely different atom. Electrons, though, can change and still have the same element. If we positively charge an atom, that is, we take away an electron, we subtract a minus, and so that makes a positive. Positively charged atoms are called cations, whereas if we add electrons, negatively charged atoms are called anions. And so let's see if we can find the number of electrons in these examples. So the first one is Fe. And so it's just iron right here, just by itself. There's no indication of any type of charge. So this guy right here is neutral. And since he is neutral, then that means they're the same number of electrons as protons. And the atomic number of iron is 26. That means there are 26 protons. That means there have to be 26 electrons. And so we've got the electrons for that. The next one here, we have carbon plus 2. Now what that would tend to indicate, and this could be the carbon plus 2, or this could also be written as just C2 like this. Both mean the same thing. This means this has a charge of positive 2. Well, let's just sort of look at this very quickly. Let's just sort of say that, let's look at our protons. Protons, we know for carbon, according to the atomic number, is 6, so therefore there are 6 of these. If this has a charge of positive 2, that means there have to be 2 more positives than there are negatives. And so if there are 2 more positives than there are negatives, that means that there are 6 protons, but the number of electrons is going to have to be 4. Because there are, in this case, 2 more positives, 2 more protons than are electrons. Note that there couldn't be 6 electrons and 8 protons. That would still be a positive 2, would be the charge, but it wouldn't be carbon anymore. That would instead be oxygen, because oxygen's what has 8 protons. So whenever you have a positive number for your charge, that basically means that you're going to have a smaller number of electrons than you do protons. So onward to our next one, our lithium minus 4, we can finally solve something for this. So the minus 4 tells us the charge. So if we once again look at our protons, we say for lithium, lithium has a total of 3 protons. And so in this case it has a negative charge. That means there are more negatives than positives. So that means that there have to be more electrons than there are protons. And how many more? In this case, minus 4, so there are 4 more. So 3 plus 4 is 7, so there must be 7 electrons here. So that's how you find the number of electrons in various things.